In this lesson, we'll talk about handling exceptions within our applications. Now, what is an exception? Well, a very simplistic way of looking at it is something unexpected that happens while your application is executing. And while this has become the default definition for the term, it's not entirely accurate. An exception is a special kind of an event that's raised by a method in a class. Now, whether that class is in the .NET Framework or a class that you create doesn't really matter. It's an event that's fired because it either meets some condition or doesn't meet a condition that was expected. It's up to every method of every class, whether we're talking about classes in the .NET Framework or even classes that you create, to decide when and why to raise an exception. Now, usually it's because there's something about the state of the application or the values that were input into the method that are somehow invalid, although that's not always the case. But at any rate, when this happens and it's impossible for the method to continue executing, the last thing that it can do is throw up its hands and raise an exception, hoping that the code that called that method can gracefully handle the situation. So what happens is that you have a method. Let's say the button one click event that we've been talking about up to this point. And the event handler calls a method of some class in the .NET Framework. Now we can build on the previous lesson. Let's say that this is the constructor of the system.xml.streamReader class. And we pass in an invalid file location to the constructor. And obviously there's a problem because the StreamReader class can't continue on, so it throws an exception. And think in terms of throwing and catching a ball, for example. The stream reader has to tell your code that something was wrong and that it couldn't continue executing. So it bundles up all the information that it can ascertain into a special object called an exception object. The exception object is then passed to the code that originally called the method, hoping that it will know what to do. And the code you've written that calls the StreamReader's constructor method can just ignore the exception, or it can handle the exception. Now, up to now, we've just been ignoring all the exceptions, so our code hasn't been very robust. It's easily breakable. However, we can write some special code that checks just in case something bad happens as we're calling the StreamReader method and ensures that if something bad does happen, our code can handle it. We do this by using a try catch statement within our code, and we'll look at this in just a moment. So when we write code, it's up to us to identify those lines of code that might be easily broken and make sure to add these try catch statements around them, and I'll talk about how to identify them also later on in this lesson. Let's talk about this exception class for just a moment. The exception class is the base class for all exceptions. So we've already encountered a few exceptions. For example, in the previous lesson we saw the file not found exception that was thrown whenever the .NET Framework tried to open an XML file but it couldn't find it in the directory it expected to find it in. The file not found exception derives from the system.exception base class. Now, why do you have to use specialized versions of the exception class? Why not just use the exception everywhere? It's really so that your code can determine the exact nature of the problem and respond to it accordingly. For example, if the exception is of type file not found exception, then there's an easy remedy for this problem. You tell the user, and then you allow them to find the file on their hard drive using some type of dialog. Or perhaps the file is corrupt. Then there's a different exception for that, which requires a slightly different error message to the end user, and perhaps a slightly different remedy in order to fix the problem. Or perhaps the file doesn't contain any XML, or any of a number of possible problems that could occur. Having these specialized versions of the exception base class allows you to pick the right course of action and then try to handle it within your application if possible. And if it's not possible, then you can tell the user that the problem, what the problem is, and ask for their intervention, like please pick another file. So in the .NET Framework, there's dozens, if not hundreds, of different exceptions that have been defined that are all deriving from the system.exception base class. And whenever you create your own applications, your own classes, you can create your own specialized versions of the exception-based class. Now, we're not going to talk about how to do that in this series of lessons, but on www.learnvisualstudio.net, we talk about that at great length. So let's continue on. let's talk about a best practice, and that is that you should anticipate the problems that can occur within your application. When you anticipate what those problems are, then you should write try-catch code around those possible problems. And if you can resolve the problems without the user's involvement, then that's great. That's what you should do. If the problem requires the user to intervene, like please pick another file, then that's okay too. But you should never just allow the application to break and leave the user confused about what to do next. So let me give you an example of what I mean. We're going to create a little application that will intentionally be easily broken and look at what happens whenever we don't handle the exceptions. And then we're going to wrap some try-catch statements around the code and see how to handle the situation a little more gracefully. So to demonstrate some of these ideas, I've taken the liberty of creating a new project called Lesson 11. And it's a simple Windows application. And on the design surface for our form, what I want to do, first of all, is add a couple of text boxes. And then I want to add a button. And what I'm trying to do is write an application so that it's easily broken. So I can do two things. I want to trigger and show what an exception looks like to the end user. And then secondly, I want to show how to add some structured exception handling in order to fix this problem. So I'm going to double click on my button and I'm going to paste some code in that I've got on my clipboard already. And so let me close some things and move some things over here so we can take a closer look at what we're working with. Okay, so first of all, in line 5, you can see that I've declared a new variable called result of type integer. And what I want to do is take the two values that are typed in the text boxes, textbox1.text, textbox2.text. I want to parse each of those into an integer data type, respectively, multiply them together, and then grab out a result. So a fairly easy operation. We're just going to take the values on the two text boxes, multiply them together, and in line 8 we're going to display them in a message box. Then finally in lines 10 and 11 we're just going to clear out the text boxes after we've gotten our result. Okay, so this is fairly straightforward. I'm going to run the application. And now if I were to type an 8 and a 7, then click our little button here, we're going to get 56 in a message box. That much works very nicely. But what happens if the user doesn't input values that are numerical? So for example, we're going to try and multiply 7 times a, and then click our button. And notice what happens. We have a runtime error. You can see that I have a format exception type was unhandled. Now this format exception has as its base type system.exception. Okay, so it derives from system.exception, but it specializes it for this particular problem. And the problem is that, as you can see here in the descriptive text below it, input string was not in a correct format. You cannot parse the letter A, I think is what it's getting at. We get this beautiful little message box here that explains what the problems are, and this is new to the new versions of the Visual Studio IDE. We get search online for more help on this particular problem and other actions that we can take. Okay, so that's great if we're debugging our application and we need to test it and see where our problems are at. But that's not the message box that your users will see once you deploy the application. So let's stop right here. And what I want to do is just go ahead and build our lesson. And then we're going to open up Windows Explorer, navigate to our project. So we'll go to Visual Studio 2005 in our My Documents folder for the current user. We'll go to Projects. Let's go down to Lesson 11. And we're going to find the bin directory. We're going to look for the debug directory. And now let's execute our application again from here. And let's put in the same values, 7 and A, and then click. Now notice this time that I get a different message box that pops open whenever this exception has been uncovered. And so we get this nasty little box, not very pretty. Unhandled exception has occurred in your application. If you click continue, the application will ignore and try to continue. If you click quit, the application will close immediately. Notice this little detail button that has a bunch of information that your end user would probably have no idea what this means. And this is for you so that it can help you debug the problem, but it doesn't do a whole lot for your end user. So ideally what we want to do is put a more friendly message. So we want to check for these kinds of problems beforehand, and then try to handle the problem for the user and give them a much more friendly way of dealing with this particular issue. So let's go ahead and get back into our code. So what I want to do is change this code and add some structured exception handling. To do that, what I'm going to do is go right above our little result state, our line 8 here, and put try, and then hit enter on the keyboard. Notice that it sets up in Visual Basic 2005 the try, catch EX as exception, and then end try. So now what I want to do is start copying and pasting some of the code from lines 13 and below into the try catch statement. Now, because I've already got some code on my clipboard, I'm going to go ahead and paste that in first. So let's just go ahead and right-click and select paste. And then I'm going to explain what this is doing here in just a moment. We're just going to take these two lines of code, cut, and paste them in here. Okay. So now I am going to attempt to execute lines 8 and 9. However, if there's any problems while lines 8 or 9 are executing, then it's going to be caught in line 11. Notice we have this catch EX as exception. So think about uh, this code in line 8 and 9 throwing a problem, and then whatever code's written in the code block below line 11 will catch it and handle it. And so what we'll do is simply notify the users. I pasted and we're going to pop open a message box. So messagebox.show, there was a problem with your entry. Please make sure you enter numerical values. And then we'll add some additional information like an input problem. This will be displayed at the top of the message box. We'll just have an OK button as opposed to a yes, no, cancel. And we'll show a little error icon as well. And then outside of this try-catch block, we're going to perform lines 16 and 17. Now notice in line 11 that we are catching the base exception. So this will catch no matter what the problem is. It's the most generic of all exceptions is system.exception. In a moment we'll modify this example in order to catch the specific problem that we've encountered so far while testing our application. Do you remember what that was called? I believe it was the format exception. So it was the specific type of the exception, but this will work as a general catch-all in line 11. So let's go ahead now and run our application, and we'll try to get the application to trigger an exception. And notice this time that I get a somewhat more friendly message box with more pertinent information for the specific problem that I'm having. There was a problem with your entry. Make sure you enter numerical values. Click the OK button to continue. And now notice that we haven't crashed. We're continuing to run the application. And the user can continue on knowing full well what the problem was. Now, we took a big assumption here. We made a big assumption that the problem that they were going to encounter was this, please make sure you enter numerical values. When in fact, it could have been a number of different problems. Had we only had more than 2 lines of code in our try statement, in our try block, there could have been 3, 4, 5, maybe 10 different possible problems. So instead of making a big assumption, what I want to do is I'm going to make some more space here between the try and the catch, and I'm going to paste in some more code. Then I'm going to comment out this line, I'll copy it, paste it again, and then cut out some of this text that's a little more specific to an exact problem. And this is more in line with probably the way that we should go about doing it. Okay. So notice now, if we have a specific exception of type format exception, it will catch here in line 11. Now, if format exception is not the specific problem that's occurring in lines 8 and 9, then it will go on to the more general exception, which will catch everything no matter what. So this is sort of a best practice. Whenever you're adding declarative or structured exception handling, as it's known, you'll want to test for the most specific exceptions first and the most general exceptions last, with the most general exception being the system.exception base class. So catch EX as exception, as I've got highlighted in line 13. So what I'm going to do here is something a little bit different. I'm going to put a breakpoint in line 8 and watch this as it progresses. I'll save everything, then run our application. So again, a times 7. Get to our breakpoint. And now I want to use the step into button on my toolbar. Notice that after it attempts to execute line 8, that it goes and immediately jumps to catch EX as format exception. And then it pops up in the message box. Okay. And it continues on. Let's go ahead and just hit run. Okay, so hopefully so far you can see the value in structured exception handling, how we're able to check for problems, especially specific problems, and then allow the user to respond appropriately. By having a more clear understanding of what the nature of the problem is, what we can do is notify them in the feedback we give them about the specific problem, or if we can handle the problem for them, say, for example, in this case, if we happen to know for our particular application that the letter A equals the number 1, we can do the conversion for them. Now, in this case, that's a very big assumption. We're talking about in a more general sense. If you can help them solve the problem, you should do it for them. If you, for example, if they were to select the incorrect file name from a dialog box, perhaps you could pop open the dialog again for them and make it a little bit easier instead of having them go through the file system. So file, open, new, you can anticipate that now they're going to need to select a new file. So pop that open for them. So there's some ways that you can handle this, what's called eloquently or gracefully, and not just allow your users to dangle out there without really knowing what to do next. So if you can solve problems for your users after an exception is encountered, you should do that. If you can't, give them as much information as possible in order for them to make good decisions about what to do next. So you might be wondering, how do I figure out that I need to use, in this case, format exception and maybe 3, 4, 5 other exceptions for this little piece of code? Well, the way you do that is through a lot of testing. Um, you can test yourself, you can have your friends test your application, and as they run into a problem, you take note of the specific exceptions that are being thrown and think to yourself, in this scenario, what could I do to solve the problem? Now, a lot of these problems can be taken care of if I were to just do a little bit of checking ahead of time. For example, I can check to make sure that these are numeric values before I attempt to do a conversion on those values. So there's some effort that I could expend up front in order to ensure certain problems never occur. Uh, as the old saying goes, an ounce of prevention is worth a pound of cure. So in this case, this is the cure. The prevention could be simply to make sure that these are numeric values that they're typing in, and then we never get to the exceptions. And that's always good. That's what we want to do. So you need to constantly test your applications while it's under development. Have your friends test your applications as well. And as you find problems, think, what would be the logical way to go about handling this? Can I take care of it? Can I do some checking up front to make sure that they've entered the correct file name, that they've uh, entered the right values into the input boxes on the form, and so forth? And if there's no way to ensure that these problems won't happen, then you have to resort to using these try-catch statements, a number of catch statements to look for specific problems that can occur. So you have to be part programmer, part detective when it comes to really fortifying your applications and making them solid. Now, let me also say this. You should not wrap every statement you ever write in a try statement. Why did I leave lines 19 and 20 outside of the try statement? Well, the reason is because there's a very low likelihood that those two lines of code will ever trigger an exception. The same thing is true for line 5, and quite honestly, line 9 might be a little bit of I could have gone either way on that one as well. I probably could have left that one outside of the try-catch statement. However, line 8 is a good candidate in this scenario because we are accepting user input. So whenever there's something that could break because we cannot control all the variables, in other words, in this case, we can't control what a user is going to type in a text box, then we should obviously do some try-catch around that. However, if there are things like declaring variables, setting objects equal to certain values, we can take some comfort in the fact that this will always work, and if it doesn't, there's probably larger problems at stake than just the specific problem that our application is having. In other words, the computer is probably having a lot of issues at this point. So then, why not wrap everything in a try-catch if there's no reason why you shouldn't do it? Then why not do it? Well, the reason is because the try-catch statement can be fairly expensive in terms of your processor's memory. Now, in a small application like this, it's going to be negligible. You're not going to be able to notice any problems with the application. However, in larger applications, web-based applications, it does take a little bit of extra effort in order for the computer, for the .NET runtime to handle these try-catch statements. So you want to use them sparingly, but whenever they're needed, whenever you cannot predict what's going to happen. For example, user input, file system, anything to have to do with an external resource. These are good reasons to use try-catch statements. Okay, so now we've pretty much talked about the basics of the try-catch statement, about structured exception handling. I want to take this to the next level, and that is whenever we're writing our own custom classes, to use try-catch statements and to pass problems that occur up from the class to the code, for example, in like a form or whatever that calls the code in the class. So what we want to do in some cases is throw an exception. We want to say, this is a problem in our class, and I don't have the ability to pop open a message box. That's not my responsibility. The responsibility of that class is for business functionality or to access a database. Its responsibility is not to display information on the screen. So it needs to communicate that there was a problem to the code that actually called it. And somewhere up the ladder, before it reaches the user, the code should catch the exception and and handle it. Either take care of it and try to handle it on its own, just like we talked about a few moments ago, or display something to the end user. So I'm going to pause the recording of the video now and add a little bit more code to set up a slightly more complex situation so we can demonstrate this. Okay, so after a few moments, what I've done was added a new class to my Lesson 11 project. It's called My New Class, as you can see in line 1. In line 3, I defined a new public function called myMethod that accepts a double that I'm calling taxable amount, and it's going to return a double, which will be the total amount of tax that's for a given purchase or whatever the case might be. This is a very nonsensical example, so we want to take this with a little bit of a grain of salt, but hopefully you can see from this how to catch and throw exceptions. Okay, now in this particular case, what I want to do is to check the value that's being input into my method. And this is a very real world example of what you'll do. You'll want to, in the methods that you create for your class, you'll want to check the values that are being input by the user of that method. So we want to make sure that the taxable amount is not over $100,000 and that the taxable amount is not less than $0. Now, in either case, what we want to do is tell the code that called our method that there's a problem, that you can't use these values. For whatever the case might be, we never sell any merchandise over $100,000, so we're not even going to try and calculate. We're going to catch this problem right here and kick it out to uh, whatever code is called our class. Okay, so what we've done in this first example in lines 5, 6, 7, we're checking to make sure that the amount is not over $100,000. Now, as you can see, I've thrown a new argument out of range exception. Where did I find this? Well, I happened to look through the help system, and I was looking for an exception that would explain the type of problem that I'm having. And I've seen this type of exception through my personal experience with developing in Visual Basic. So this was very easy for me. I happen to know that it existed, but it does take a little bit of experience, a little bit of time going through the help system, and I wanted to reuse or repurpose this exception that's already been defined by the .NET Framework. Now, I could have done the same things in line 9, 10, 11, and 12, where you can see I'm checking for the opposite. If it's less than 0, then I want to throw an exception as well. Now in this particular case, I could have used argument out of range exception, but I chose to do it a little bit differently just so I could show you what happens when you can't find an existing exception object that adequately explains the problem that you're having. So in this particular case, what I've done is dim ex as new system.exception. Taxable amount must be greater than 0. So I'm giving a fairly good description of the problem that we're having, but we're wrapping it in the message property of the system.exception object and then throwing that. Now, what is this throw statement? What does it do? Well, it basically creates a new instance of this particular object. In this case, it is the argument out of range exception or the system.exception, and then it delivers it to the code. It stops the execution of our code at this point or at this point, whichever one's reached, and it tells the code that called this method that there's a problem and it delivers this information to it. Okay. Now, if it were to pass these two checks and we don't throw an exception, then we'll go ahead and calculate the tax and return that back to the code that called it. So let's look at the code that calls this method within our little sample application. So you can see here that I've got a new button that I've added to the form, and I've added a little bit of code behind that button. In this case, I'm taking the value out of text box 1. We're going to parse it to a double and store it in taxable amount. We're going to create a new instance of my new class and an instance of a double called result. We'll gather back the information from the application. Now in this case, I have my new class.myMethod, and I send in the taxable amount. I grab in the result and I display that in a message box. So let's go ahead and run our application. We already know what's going to happen if we were to put in some bad value. So for example, 101,000 approximately. Click button 2. And we get this argument out of range exception was unhandled. Why is it unhandled? Why are we getting the exception here within our myMethod class when really the problem was in the code that called it? Well, it could tell that this was the origin of the problem, and there was no code that handled the throwing of this exception. So let's do this. Let's close this down. Let's stop, and let's write some structured exception handling code here to handle this problem. So let's do this. Try. We'll grab all this. And what we're going to need to do is create two versions because, as you recall, we have a specific problem. Whoops. Catch ex as argument out of range exception. So here we might do something like this. Messagebox.show. And then we'll do something like please enter a value less than 100,000. Okay, and here we might just do something like this. Messagebox.show, and we'll just take ex, which is going to be our reference to the exception object that was thrown. So ex.message. So we'll grab the message that was created over here in my new class.vb. As you can see, as we're creating a new system.exception, I passed in a message in the constructor. Okay, this is what's going to get displayed then. So let's go ahead and run our application now. Let's go ahead and do this, 110,000 or whatever, and then click button 2. And notice I get this, please enter value less than 100,000. So then let's change this to -50, and we see that we get the message, the taxable amount must be greater than 0. So we've looked at two distinct ways of sending information back, through throwing a specialized version of the exception object or throwing a general version of the exception object, providing a message within the constructor. Either way, we're displaying some helpful text as a result of catching either of those exceptions. Okay, so we talked about quite a bit in this lesson. We talked about structured exception handling or declarative exception handling. We talked about how to use the try-catch statement and that we should try to catch more specific exceptions before the more general exception types. We talked about how to create and throw from one layer of our application, in other words, of business classes, to another layer of our application, for example, the presentation layer for our application, and how to transfer information that there was a problem from one layer to the next using the throw statement for either very specific or very general exception objects. Now, if this doesn't make a lot of sense, don't worry. Just wanted to introduce the idea that there's something called structured exception handling, that there's this try-catch statement that we can use in order to bulletproof our applications, make sure things don't go wrong, and when they do, we can handle them gracefully. And the coming videos, as we're building our RSS Reader application, I'll try to work in some concrete examples of communicating exceptions from one layer to the next, so that we can see that, and also just using try-catch in order to give good feedback to the end user of our application. So I hope you're enjoying this series of lessons. If you are enjoying them and you want to extend your knowledge past this first series, please visit www.learnvisualstudio.net to download over 450 videos just like this one on many different topics regarding the .NET Framework, C#, Visual Basic, ASP.NET, and more. Thank you.